Hey everybody, how's it going? So I paired up with my very good friend Gaurav Sen. He's a popular YouTuber who does videos on software engineering, algorithms, interviews, all that good stuff. And we decided that we wanted to do a real mock coding interview for all of you to watch. So I interviewed him in a sort of 45-minute format on a Google Doc. And this is the video that you're watching. Since it is a pretty lengthy video, we decided to cut it into two parts. The first part of the video, or the mock interview, is on his channel. The link is in the description below and in the comments below. Go check it out. And then the second part is here. Now I want to say one quick note before you continue watching. Unfortunately, we lost the footage that was recording our screen when he was typing out his stuff on the Google Doc during the interview, which is, of course, a really important part of the mock coding interview. So we had to pull a lot of magic to try to reconstruct the video, like his typing, by doing a bunch of, undos and Control-Z in the history of the Google Doc and then redoing everything. So hopefully the final product is still good because you can hear us in real time and everything. It just might look a tiny bit odd because you won't see the actual typing. You'll see more like words appear one after the other in the Google Doc. But I think you'll still find this very enjoyable to watch and very informative. So then in the interest of time, we have 20 minutes left, so we're roughly at the halfway mark. Let's try to code this out.
All right. To code this out, I am going to do a depth first search. So I just need a depth first search, which is going to end up giving me a set of nodes. These are the parents. So if I call it the parent, let's say. So the return value is a set of nodes, which are the ancestors actually of this guy. We take a node and do a depth first search on that. Okay, and we have targets also. So node target 1, node target 2. My naming has improved a lot, I'm sure. And here's boss. Okay. So we have. How do I go about this? I go to the children and then I search. Okay, so for every child in boss dot what did I name it as, reportees, I'm going to be checking if they are target 1 or target 2. So if child dot equals target 1 or child dot equals target 2, then I need to store the ancestors of this guy, which are currently in a stack. So should I make this a global variable or should I just pass it in? I think I can pass it in, although it kind of pollutes the function, but it's fine. Node, what do I do here? Ancestors. So this is going to be a copy of the ancestors node. All right. So okay. If this is the case, then I'm assuming there's a library function. Is that all right? Which takes a copy of an array.
Sure. Yeah.
System dot copy, and I don't really remember the syntax, but it's similar. So I take ancestors, I pass in ancestor copy, and now I assume that I have this in the ancestor copy, and I return ancestor copy.
So just to clarify, so
yeah.
Oh, whoops! Did you?
I just went to the next page.
Yeah, this is where Google Docs is a little bit shaky. But so could you just walk me through conceptually, like your your coding logic, like you're calling DFS
Yeah.
with
So
both targets at the same time.
initially, what I'll be doing is I go to the parent node. I pass in. I call DFS on the parent node. I should say the root node with the
Right.
two targets, and then I pass in the set of ancestors that it has till this point, which is going to be an empty array. In case I see that one of the reportees is a target, all right, okay, there's an edge case here. What if, taking example, just 3 nodes, CEO and me and another guy, then what ends up happening is if we are looking for the lowest common ancestor between the two of us, that's the CEO, and I'll end up returning at this point. At my point, I'll just end up returning very quickly, which is fine. But there's another case. Let's take a linked list kind of tree. So there's A, the child of A is B, the child of B is C. C has their manager who's B, so the lowest common ancestor is actually P. But instead, what's going to happen is I do a DFS, I go to B, and I immediately return, saying that I found B's ancestor to be A, and then I just go ahead. All right. So what I can do now is just pass in one target and run this function twice.
Okay.
And also in the target, I should be adding myself. So if the child equals the target, I mean I have found the target, so I'm also an ancestor of this thing. So ancestors, I can just add it over here. Ancestors dot add child. No, it's going to be over here. Excuse me. Okay. Now what's going to happen is the moment I find a target, I have the set of ancestors including that target, and with the second node I can just compare the two ancestors. So this seems fine.
But so right now you are only adding an ancestor to the array of ancestors if you find the target.
Yes. So this is the base case. Now I need to go for the normal case, the recursive case.
Gotcha.
Right. Okay. So for each of the reportees, if I found the child, then I'm done. I just return immediately. However, if I don't find the child, I'm going to keep on recursing. So I'm going to be adding this to a stack. Now, I think what I can do is I can just, instead of passing this, keep a global variable, private string stack string. Okay, and instead of having ancestors all over the place, I just have this.
Okay.
Yeah. Now I just need to think of the recursive way. Okay. For each of my children, my reportees, I need to run the DFS recursively on them. But instead, what I can do is, if the child is this, otherwise, just add this guy to the stack, or you don't need to add him to the stack. You can just do this, and once I've added him to the stack, I just go down to else, and then call DFS on who's the boss here. The boss is the same. So maybe I can actually get rid of this too. Can I? No, the boss. This is the current node. Yeah. So current node, and I'm looking for the target, and also not really current, so it's going to be the child, which is going to be either finding the ancestor or not finding the ancestor. All right. So here's the thing. I have, let's say I go to the left subtree and I don't find the node there. So what will end up happening is I'll get an empty array. Okay. So there's another base condition to take care of. If I don't have any reportees, then I return an empty array. Okay. So I don't have any reportees. I return an empty array. Amongst my current reportees, if they have already been, no, this is fine. This is fine. I add the child to the ancestors. I call the recursive function, which is actually not going to be returned. I'm going to be checking here. Oh God. Okay. It's kind of scary.
So
There's just 10 minutes remaining.
Step back.
I'm sorry. Yeah.
Let's take a quick step back. And okay, so you have your node class. Fair enough. Okay, you've got your LCA main class. So you've got this stack. That's a global variable, right? And then we can forget about the main method for now. Your DFS. Let's walk through it line by line very quickly.
Yeah.
So it takes in a node, which is sort of the current node that you're at, as well as your target. Your target is the reportee that you're looking for, right?
Yes.
And it's going to return an array of nodes, which are like the ancestors leading up to your target, right?
Right.
Okay, so you say, if you're at a point where you have nothing, you return...
I return nothing. So if I say there are no ancestors here,
or no reportees here.
Yeah, then there are no reportees here. That is, I can just return a null too. So
right, exactly. Because you don't need that. You don't need anything at that point anymore.
Yeah, I don't need to create an array for this.
Okay. Otherwise, you go through all of the reportees at a given time. So let's say you're at the top. You go through your two first reportees.
Yeah. And at every point of time, what's happening is if I see that I've found the target that I was looking for, the child is the target, then I return all my ancestors up to this point. Otherwise, I've already added this child as an ancestor. I do a DFS on the child, and if this gives me a result, this gives me a non-null, I should say a non-null result, that means that the child exists here. I have the result in my hand, and I can just return that. On the other hand, if it doesn't, then I continue doing this for the rest of the reportees that I have.
I see, but then do you need to add some kind of check on here on this DFS call?
Yeah. So the check is if it's null, then do this. If it's not, then return the ancestors. So I'm just going to be saying, what's this again? Node array result equal to this if the result is null. In fact, if the result is not null, then I just need to return the result. Otherwise,
and so sorry, go on.
No, I'm just wondering if I have the result returned and that is the set of ancestors they have, that's fine. So I'll just need to call this function twice. I'm sorry, you were saying something.
Yeah, so just here on this line where you do ancestors.addChild, do you mean ancestor copy?
Oh yeah, I actually need the stack here. So I need stack.addChild, and once I have added this person, I have gone through all I've gone through the entire path in this child. If the result was null, then it doesn't make sense for me to, I am going to the next child. So what I'll end up doing is removing this from the array. So stack.pop.
Okay. Okay. Now this makes sense with the popping, because I was about to say, like, yeah, you would if you went through an entire subtree and didn't find anything, and then you find yourself at the next subtree and you've got like this huge stack of randomness, but no, you're popping them every time.
Right. So now I'm mainly concerned about trying to actually, the main function can probably handle this. But yeah, I'll just have a. I'm sorry, I'm just cutting you off.
No problem. Keep going. We've got a little bit more time left. Still about 5 minutes.
Okay, so the node LCA takes the. Does it take the boss? Yeah, it does take the boss. So it takes boss node report T1 and the report T2. Okay, and what this needs to return is a single node.
Yep.
And also now what I need to do is I just need to do a DFS on boss and report T1, which gives me ancestors 1. This is ancestors for 1. This is awesome naming, but yeah.
I mean, it's probably as clear as it can get for this type of question.
Right. So we have ancestors 1 and ancestors 2. Now I just need to head straight ahead with these two guys. So for int I equal to 0, I less than, what do we have here? Ancestors dot length and I less than ancestors 2 dot length. I'm going to do increment I, and I'm sure that I will have found one common ancestor definitely over here. Okay, so here's the thing, it's not possible that both of them are the same unless you have passed in the same reportees. If you have passed me
yeah, for now, let's forget about the edge cases. Like we said, like they're never going to be the same. They're always going to have a lowest common manager.
Yeah.
Maybe in the future we could expand the function to handle these edge cases, but for now, let's forget about them.
All right. So we have if ancestors of I plus 1, ancestors 1 of I plus 1 is the same as ancestors 2 of I plus 1. Then I keep heading forward. Then I don't do anything, in fact. I just need to see if they're not the same, and then I return this particular guy, the one I have right now. Okay, this seems reasonable. This is a single node. So if they're different, if the one to the right is different, then I know that this is the last node which is common, and I return. And
right.
I'm sure that this is going to work because this is not going to basically throw an out of bounds exception, because if ancestor, so I can handle that in the main function. If they're both the same, then just return the node itself and stuff like that.
Wait, so will you never get out of bounds here? If you are dealing with,
so if I'm dealing with, let's say, yeah, two different nodes. If I'm dealing with two different nodes, it's definitely not going to go out of bounds.
Right. Assuming that they always have a lowest common manager and that they're two different. Yeah, basically, if we ignore those edge cases that we talked about, this is correct. You're right.
Yeah, if they are the same, then I'll handle that in the main function. I can immediately just return the result. I can say that they're the same.
If they can have, if it's possible that they don't have a lowest common manager, then you could have all kinds of stuff, but We said to ignore that, so that's good. Cool.
Yeah. How is it possible that they don't have a lowest common manager?
If it were possible, meaning I give you like in the example, imagine I had given you never mind. Never mind, it's not possible.
All right. Oh, thank. So yeah, maybe the code quality is really poor, but this is yeah. All right. I mean, of course, you will be deciding. So yeah.
Okay, so we still have we have 20 seconds on the clock, and typically we would have actually like 5 more minutes. So I just want to cover a couple more things. So you covered the out of bound thing. Just in your thing here. Oh yeah. So can you just walk me through? Let's see if we can walk through this algorithm on the input as a final thing.
Sure. So let's take this. I'll just copy that and.
Yeah, if you can copy it down here.
This should be
maybe like above here.
Yeah, perfect. Okay, so here's the algorithm. We have initially A being passed in and the target being E. So let's see. I come over here, I see that the reportees are greater than 0. So first I take B and my stack I add B. So let's just have the stack. Oh, actually, yep, there's a there's a mistake here. I need to add to my stack, maybe in the main function itself, A. So I need to add the root in the main function itself.
Sure.
All right, so I'm going to assume that I have done that, which is something I had not mentioned.
So above ancestors, one thing here. Okay, I'll add it for you, but we understand.
Right. So if that is done, then we go to B, which is the first reportee, and we add that to the stack. We say that is it the target? No. We come here with the ancestor copy. We no, I mean we don't do this. Of course, we go here and we call a DFS on that. So fine. We do a DFS on that. We go to D, which is the first node. Reportees are greater than 0. Add that to the stack. I have D, and what do I have here? I again go to a DFS on H.
Yep.
H has been added to the stack at this point. I go down here, I see that the reportee are 0, so I return null. Null goes back to D, which then sees that this is null, so I just pop from the stack. So I pop H from the stack. Okay, seems to be making sense. I now go to I, which is the next child in this for loop. I then state that, add that to the stack. A similar thing happens at which I gets popped out. D now has null and null. And it returns. It returns what? Where's the return statement here? What happens if nothing happens here? So I actually need to return here. That's another mistake.
Okay.
Okay. Now that I have returned, return null. There's B, which sees that this result was null. Pops D from the stack, and now E goes in. E is a target. We come all the way over here, which is, I mean, it was the next reportee was E, so we see that E is the target. There's a copy of these 3 nodes, so these 3 nodes are copied down and then sent back. All right.
And just to clarify, this is a Java question for me. Here you're declaring ancestor copy as like this array in this line.
Yeah.
Okay. Yeah.
Yeah. Here's a problem. I haven't reset this. I haven't reset the stack here.
Yep.
So what I should have done was
initially
just initialize this stack function. Okay. I mean the stack thingy. So stack equal to new string, let's say of the size of the tree if I had that, which is another thing I should have taken care of. And then again I state that this is a fresh stack.
Yeah, or you could, yeah, exactly. You could you could pass a new stack however you want, or you could move it out of a global variable and pass it.
Yeah, I could have probably a list also over here because it's going to be order n down here. So I could just have a list, and I could make a copy of the list itself, or convert it to an array.
Okay, cool.
Yeah.
And then so then we run it again, and then for your for loop, I think your for loop looks correct. It looks correct.
Okay.
Okay, so I think we're out of time, Gaurav. So thanks a lot. I hope you had fun. I hope this interview was fun. I hope you had a good time, and best of luck for the rest of your interviews today.
Thank you so much. May I ask you a few questions?
All right. So at this point, we can do maybe the debrief. That was the full interview, everybody. Hopefully you had a good time, Gaurav. So before we jump into the debrief and I tell you sort of my thoughts, I'm curious, what are your thoughts coming out of it?
So the coding was very rusty. The algorithm maybe was solved while you were talking, to be very honest. I wouldn't say that. So I had a rough idea of what's going to happen. We need the lowest common ancestor. There's some standard ways. If there's lots of queries, then I would have gone for pre-computation. This was a single thing, so the graph search came into mind. So I think I was quite confident when it came to solving the problem on the whiteboard or in theory. But when it came to coding, there were, according to me, a lot of mistakes. Simply put.
Yeah. So okay, I'll give you my assessment. Okay,
sure.
And again, I'm going to try to be as objective as possible. I think here, as far as I'm concerned, I would have probably given you like a higher decision or recommendation, meaning like that's basically like almost the best. Almost like a strong higher. I maybe would be in between higher and strong higher. For a few reasons. So congratulations, Gaurav.
Yay!
So there are a few reasons. First of all, I think that there are a few things that you did very well. I think you communicated very well. At the beginning, Gaurav asked a lot of like questions and clarified things, and he was speaking through his thought process a lot. I didn't feel like confused at any time, and when I did, I just interjected. And then also, I think you asked good questions about like, should we handle this edge case? And my answer was no, you don't have to, which actually like simplified your life, which is again like a big reason that communication is very important. You did very well on the sort of like algorithm section, right? You came up with a solution. By the way, this is not the solution that I was expecting. This is a question that we have on algoexpert.io. Check it out if you want to prep for coding interviews. But
you can use this coupon code Gaurav to get a 30% discount.
You can use Gaurav, algoexpert.io/Gaurav for a discount. So we have a solution that probably runs a tiny bit better in space complexity, same time complexity, because we don't store the stacks. We just do it all recursively, like throwing back the information sort of upwards, if that makes sense. You can check it out, the solution. It's a complicated one, though, to come up, I think, in like 40 minutes. So I think your solution was kind of like, it sort of impressed me because I'd never thought of it, but it made sense, I think, under this time pressure. Also, the part where you go from left to right to find the lowest common thing was like very nice. Like at first I was like, this isn't going to work. This is going to be really difficult because I was thinking from right to left and you'd have to do like double for loops or something. And I was like, this is going to blow up the algorithm. But no, it's very, very ingenious to go from left to right. And yeah, then now we get to the, by the way, in terms of like your pacing, I think that was good. You went at an appropriate speed, if not faster than expected, very respectful, all that. The coding is probably the weakest part here, like you said. Well, first of all, as a side note, I would personally not interview in Java just because like I don't really know Java. I know it enough to be able to like follow along, but I'm not sure if you made like really bad syntactic mistakes. I don't think so. You got off easy if you did make some. But like I think the coding, the one thing where there could have been improvement, in my opinion, is maybe trying to like voice out loud, or not even voice out loud, but like outline all the steps in your algorithm more before you jumped into it. Because I think you kind of wrote it as you went along, and you ended up like that's why you missed a couple things at the end with like the resetting of the stack and all that. But yeah, overall, like you got the solution at the end when you ran through the test case, which is like a very good thing, by the way. Always do that. Always go through the input if you have time, and even other inputs if you have time. You caught all the mistakes, some of which I hadn't caught, like the stack emptying and all that. And yeah, I don't know. Overall, very good job. I would like as far as I'm concerned, I would recommend a hire for this. So.
You hear that, guys? I still got it, huh? But I have to say, I was pretty. So I don't know. It's a different kind of scenario. In this, on the YouTube video, there's the thing that everyone is watching. That's the kind of thing that I have in the back of my head. In a real interview, I would be worried about the result because, I either get placed or I don't. And I think one of the important things to keep in mind is, despite being, practiced with algorithms, despite having a degree or not, what's the most important thing is, I shouldn't say despite being practiced, I should say having the knowledge of this algorithm doesn't mean that you can solve it within 40 minutes. So that's really something that struck me as the most important thing. Like you said, coding. Usually when we are at work, we have a lot of time, and we are given that time so that we can think over what we are going to do. We are going to make this nice, and we are going to refactor this bit while touching this bit, and there's a lot of things which go on. But in an interview, you need to get the solution fast.
Exactly, and I think that like to your 2 points, the first one about like it can still be hard even when you sort of know the algorithm, or when you're very well versed in algorithms, like you are. Like you're very good. You're obviously very good at this, right? However, like you immediately recognized lowest common ancestor, and you kept using the word ancestor, even though like I framed it as lowest common manager. I kind of adorned that question with but even though you had probably heard of lowest common ancestor before, like it was a difficult question because like it's not like you're doing this question every single day, right? And then the second thing that you said about the coding, that is a key point that should be like encouraging, I would say, for anybody watching this, is that at the end of the day, yes, you are under time pressure. Like you will not be expected to code something perfect. And by the way, if you look at the solutions on AlgoExpert, some of them, or most of them actually, all of them, right? We spend a lot of time trying to give the best solution. So, you might be like, I would never come up with this perfect syntax where like everything is like clean with the perfect variable names and everything. You want to strive for that, but it's normal that you will not reach that in 40 minutes under time pressure with all of YouTube watching, or with the job on the line, or whatever.
I didn't know that AlgoExpert actually has this question. I hadn't gone through this one. Thanks so much, Clement.
Cool.
And
thanks.
Guys, do check out his website, definitely. It's worth it. All right, see ya.
All right.
Bye-bye.
See you.